So now we're going to have a look at Theorem 9. So this says that in a parallelogram, opposite sides are equal and opposite angles are equal. So let's draw a parallelogram. There's not much in this diagram. We just have a parallelogram like this. Let's call it A, B, C, and D. We're not going to mark in any angles yet because we're going to do a construction in a second. So we just hold off marking in the angle. So this is our diagram. What we're given, very simply, is a parallelogram A, B, C, D. Okay. And what we want to prove, we need to prove a couple of things. We need to prove that AB equals DC. We need to prove that, so AB, this side, equals this side down here. We need to prove that AD, that side, equals BC, this side here. Guess we need to prove that DAB, so this angle here, alright, so starting from D, going into A and out to B, so the measure of the angle DAB is the measure of the angle, this one down here, so DCB. And last of all, we want to prove that this angle at D, so ADC, is equal to the angle at B, so ABC. And we could have called, these angles slightly differently. Instead of ABC, we could have said CBA. There'd be no problem there. So the construction has the trick in it. So for the construction, what we're going to do is we're going to draw in a diagonal. Doesn't matter which one we draw. So let's say we draw this one here. To draw in a diagonal, let's mark in the angles 1, 2, 3, and 4. And what we're going to show is that the triangle ADB is the same as the triangle CBD. So we're going to show that this triangle and this triangle here are congruent. Okay. In order to do that, we'll just remind ourselves, we're going to mark this in just to remind ourselves that they're parallel, and we'll put these in here to remind ourselves that this side and this side are parallel. Okay, so the construction. So draw the diagonal from D to B, and because we just drew the line, we're going to put that line segment, just because we drew the line segment, we're going to put those brackets around it, and we mark the angles 1, 2, 3, and 4. Alright, so in order to show that they're congruent, let's just have a quick look back, see how we're going to do this. So what we do is we say, well, the angle 2 is the same as the angle 4. You have a line here parallel to another line down here, and this one is cutting them, so these are alternate angles. In the same way, this line and this line are parallel, so that means that 1 and 3 are alternate angles. And finally, DB is in both of the triangles, so DB is a common side. So by angle side angle, the triangles are congruent. So we're going to show that, and then there's just one thing you have to be careful of when you're doing this, which is to make sure that you get the right sides matched up with the right sides in one triangle matched up with the right sides in the other triangle. So the proof. The first bit says the measure of the angle 1 is equal to the measure of the angle 3, because as we said, they are alternate angles. Okay. The second bit we said was that the angle 2 equals the angle 4. Again, they are alternate angles. And the third bit we said was that the measure of the side DB equals the measure of the side DB. And what we write here, when you've got a side that's in both triangles, you write common, as in it's in common. It's in, or if you want, you can write in both triangles. So just to label them there, we have an angle, we have an angle, we have a side. So by angle side angle, the triangles are congruent. Now this is where you have to be careful. The triangle ADB is congruent to, now this is where we're going to go back to the diagram. I think it's pretty clear that when I'm looking at this triangle matching up with this one, then this angle and this angle match each other. They're the two obtuse angles, so they're going to match each other. The problem is, if I fold over a parallelogram along the diagonal, if I fold it there, A probably isn't going to hit, sorry, I'll give it that pen. If I fold it along the diagonal, A probably isn't going to hit C. It's going to come down over here somewhere. What that means is that the side AD is not going to be the same as the side CD. It's not going to match that. And after all, these angles don't match. These two angles don't match here. So it's not that ABD equals CBD. Okay? And you have to be careful when you're doing, sorry, ADB is what I'm looking at. So you have to be careful when you're doing congruent triangles that you match the right points up to the right points. So A is going to C for sure. But if I look at this triangle here, the angle 1 is at D. And in this triangle, that matches the angle 3. So for ADB, I'm going to have CBD, because up on the top triangle, you have 1, that matches 3 on the bottom triangle. So it's like A gets sent to C, A is the same as C, has the same angle as C, D has the same angle as B, so this angle D here has the same angle at B, and when I'm over here, B has the same angle as D. So this is the triangle ADB, this is triangle CBD. It's just important that you get the order right. It's not the end of the world if you get it wrong, but when you're thinking about congruent triangles, you really need to think carefully about which sides in one match with sides in the other. So ADB is CBD. Alright. And now this gives us everything that we want. So therefore, the side AB equals the side DC. The side AD equals the side BC. Alright, so they come straight out of the fact that they are matching sides in corresponding triangles. So you have CB is the same as this side here, AD, and AB is the same size as this side down here. We also get this angle here equal to this angle here. Alright, so DAB equals DCB, so that comes straight out. Whoops, we better put in an angle sign. DAB equals DCB. And then the final thing is we want to show that ADC equals ABC. So just coming back here again, we want to show that ABC, so this whole angle, equals this whole angle. Well, that's true because 2 and 3 equals 1 and 4. 2 and 4 are the same, 1 and 3 are the same, so 2 and 3 equals 1 and 4. So just to fill this in, so these are corresponding sides in congruent triangles. This last one here is because 2 plus 3 equals 1 plus 4. Can we see? Yeah, we can just about make that out. So this one is true because 2 plus 3 equals 1 plus 4, and this one is corresponding angles in congruent triangles. So corresponding angles or matching angles or whatever you like to call it in congruent triangles. So that's it, that's the proof. So once again, the main thing is the construction. We draw a diagonal, we show the two triangles are congruent, and really the only thing to be careful of is that you get the order matched up. So in this triangle here, you have the angle 1, it matches the angle 3 in this triangle, so wherever D is in this triangle, that'll be where B is in this triangle. So A goes to C, D goes to B, and B goes to D. All right.